we thought we understood, there lies a truth powerful enough to shake our sense of place. The real size of the universe is so vast that Earth, our beloved home, becomes nothing more than a drifting grain of dust in an endless cosmic sea. This video will guide you through layers of space where every notion of big and small dissolves, inviting us to ask, where do we truly stand in this immensity? Share your thoughts in the comments. Each reflection is a star lighting this journey. And now, we begin with the first question. How small is Earth in the universe? Have you ever wondered whether Earth is truly as vast as it feels beneath your feet? From where we stand, this world stretches in all directions like an endless cradle of mountains and oceans, a boundless home where every memory unfolds and every dream learns to walk. It is no surprise that for most of our history, humanity believed Earth was the center of all things. But the moment we lift our eyes to the sky and ask a single question, how small are we really? Everything begins to shift in gentle but irreversible ways. Astronomer Carl Sagan once said that astronomy is a humbling and character-building experience. And it is only when we dare to zoom outward that the meaning of his words settles into the quiet chambers of the mind like falling stardust. The horizon tricks us with its calm curve. The oceans mask the finiteness of our world. The mountains offer illusions of scale that comfort the heart. But the moment we lift, even a little above the atmosphere, Earth becomes a delicate blue sphere hanging in the dark like a lantern kept alive by breath alone. Astronauts often struggle to describe the first time they see this sight. Some say the planet looks impossibly alive. Others say it feels painfully fragile. From low orbit, Earth still feels large and full of presence. Yet when we drift farther toward the orbit of the Moon, our home shrinks into a glowing marble suspended in a sea of black silence. The farther we step away, the more the world fades into a whisper of itself. At the distance of the outer planets, Earth is gone beyond sight, replaced only by the thought of its existence. Voyager's pale blue dot image captured this truth in a single pixel scattered through sunlight, reminding us that everything we know rests inside a speck almost too faint to notice. Brian Cox often reminds audiences that we live on a small rock orbiting a star that is one among hundreds of billions in a galaxy that is itself unremarkable in the grand architecture of the universe. His words are not meant to diminish us, but to awaken us. As we zoom through the solar system, we begin to realize that the sun's enormity dwarfs every notion of scale we once held. Our world could disappear inside it more than 1,000,000 times, and the sun itself is only a medium-sized star drifting in a vast galactic ocean. The Milky Way extends for 100,000 light years, and our solar system is merely a grain of sand somewhere along one of its quiet spiral arms. From this vantage, Earth is no longer small. It is essentially invisible. And yet, we are still not done shrinking. As our imagination floats beyond the boundaries of the galaxy, we see it become just one shimmering ember among hundreds of billions of others. Even the largest galaxies we know, titanic whirlpools of light spanning millions of light years, are themselves tiny patterns sewn into the cosmic web. This web stretches across the observable universe in filaments and voids so immense that they stretch comprehension until it bends like soft metal. At this scale, the question "how small is Earth?" becomes almost meaningless. It is not small. It is below small, below measurable. a presence that dissolves into the cosmic fabric like a grain of pollen lost in a storm spanning eternity. Scientists such as Neil deGrasse Tyson often remind us that the universe is under no obligation to make sense to us. Our minds evolved to measure the distance between trees, not between galaxies. We are creatures of valleys and rivers, not of light years. So when we confront numbers like 93 billion light years, our intuition simply collapses. And yet the collapse is strangely liberating. When I reflect on Earth's smallness, I do not feel despair. I feel serenity. There is a meditative softness in knowing that our daily anxieties, our struggles for significance, our unending chase for perfection, all unfold on a world barely large enough to hold a pixel of light. The universe does not mock our concerns, but it gently whispers perspective. Einstein once remarked that two things are infinite: the universe and human stupidity, and he was not sure about the universe. The humor conceals something profound, the recognition that our egos tend to inflate far beyond the physical reality of our place in the cosmos. When Earth itself is but a tiny grain drifting in a massive tide of galaxies, how can the boundaries we draw between nations, the arguments we carry in our hearts, or the grudges we refuse to release, hold any real weight? There is something deeply healing in this realization. It allows the mind to loosen its grip, to breathe a little more deeply, to see life with a gentler gaze. When we meditate on our smallness, we do not diminish our worth, we illuminate it. Because despite being nearly non-existent in size, Earth holds something the vastness of space may not: life. And not just life, but consciousness, awareness, a spark capable of wondering about its own origins. Among billions of barren worlds, oceans of hydrogen and helium, galaxies colliding in silent violence, here we are, thinking beings made of carbon and stardust, asking questions no other species we know has ever asked. This is why Earth's smallness becomes its miracle. The universe is enormous, but perhaps only a few corners of it can dream. Only a few atoms can rearrange themselves into stories. Only a few worlds can look outward and feel awe rising like dawn within them. When I reflect on the cosmic scale, I find myself returning to a simple truth. Value does not come from size, but from meaning. Earth may be physically insignificant, but it is emotionally infinite. It carries every laugh, every sorrow, every symphony, every poem, every whispered hope across 1,000 generations. No galaxy can compare to that. And so, the lesson becomes as soft as it is powerful. When you feel overwhelmed by the scale of the universe, remember that your life, though small, contributes to the only known place where the universe can reflect on itself. Through us, the cosmos awakens. Through our questions, it learns to ask. Through our wonder, it learns to feel. As the mind drifts deeper into this meditative river, the noise of the world fades, leaving behind only the gentle rhythm of existence. You might lie down beneath the night sky and sense yourself floating with Earth through the vast cosmic web, a small but luminous traveler in a universe that does not need you to be big, only awake. And as this awareness settles, another question rises softly in its wake. If this is only the beginning of understanding our home's true scale, what deeper mysteries await us as we continue exploring Earth's delicate place in the grand tapestry of the cosmos? Have you ever looked up at the moon and felt that if you simply stretched out your hand just a little farther, you might almost touch it? From the ground, it looks so close, so familiar, so gentle, that it feels more like a lantern hung above our world than a distant celestial body. Yet, the truth is that the distance between Earth and the moon is so vast that our intuition quietly breaks when we try to grasp it. The human eye compresses the sky into a comforting dome, and in doing so, it tricks us into believing that the moon is just beyond the clouds, when in reality it is almost 400,000 kilometers away. Far enough that you could line up about 30 Earths in the gap between the two worlds. This mismatch between perception and reality is not a failure of the mind. It is simply proof that our senses evolved to navigate forests and valleys, not cosmic distances. Our ancestors did not need to know how far away the moon really was to survive the night. They needed only to know when it rose and set, how its light softened the darkness, and how its phases marked the passing of time and tides. And yet, as soon as we began to measure the sky with reason and instruments, the moon transformed from a mystical disk into a neighboring world with an orbit so wide that it makes our planet feel smaller than we ever dared to imagine. Astronomer Neil deGrasse Tyson likes to say that the universe is under no obligation to make sense to you. The Earth-Moon system is a perfect example of that gentle cruelty. To our eyes, the moon is an ornament in the sky. But to physics, it is a massive companion, sculpting the rotation of our planet, stirring our oceans and quietly guarding the stability of our climate over millions of years. If you could shrink the Earth down to the size of a small marble and place it on a field at night, the moon in that scale would be another smaller marble placed about 7 meters away. Most animations and textbook diagrams bring the moon much closer because if they drew it to scale, the pair would barely fit on the page, and the emptiness between them would seem uncomfortably large. That empty space is what our minds resist. A silence so wide that light itself takes more than a second to cross it. Yet that gap is real. And within that gap, the subtle dance of gravity plays out a story that shapes almost every aspect of our world. Without the moon, Earth would be a far less stable home. Our planet is tilted relative to its orbit around the sun. And this tilt is what gives us seasons. The moon's gravity acts as a kind of cosmic gyroscope, damping wild variations in that tilt over long stretches of time. Many planetary scientists believe that without such stabilization, the axis of Earth could wobble chaotically between extreme angles, throwing climate patterns into violent swings that might make it much harder for complex life to thrive. In that sense, the moon is not just a pretty face in the sky. It is one of the quiet architects of Earth's habitability. Our oceans feel the pull of this companion world every day. The tides rise and fall as the moon's gravity pulls on the calmest water. And in the shallow fringe where ocean meets land, life first learned to crawl from sea to shore. Some evolutionary biologists have suggested that those rhythmic tides may have created unique environments of alternating wet and dry conditions, encouraging early organisms to adapt to both worlds. In that storytelling sense, the moon is part midwife and part choreographer in the drama of life on land. Neil Armstrong stood on that distant surface and spoke the words that would echo through history. One small step for man, one giant leap for mankind. In that, the moment the illusion of distance collapsed in a new way. For the first time, a human being looked back at Earth, not from the air or from orbit, but from another world in the sky. The photographs brought back from Apollo show our planet hanging alone in space. A delicate blue sphere so small that it seems almost shy against the black backdrop. These images forced us to confront an unsettling truth. The distance we once imagined as symbolic and poetic is harshly real. We truly are separated from our lunar neighbor by a gulf so large that once the spacecraft leaves Earth, it is entirely on its own. And yet within this gulf lies one of the most exquisite coincidences known in observational astronomy. The Moon is about 400 times smaller than the Sun, but also roughly 400 times closer to us, meaning that from our viewpoint, they appear almost exactly the same size in the sky. This delicate geometry is what makes total solar eclipses possible. When the Moon passes directly in front of the Sun, it can cover the solar disk so perfectly that the bright face vanishes and the pale, ghostly corona blooms into view like a crown of fire. Brian Cox and many other science communicators often describe a total solar eclipse as one of the most awe-inspiring sights a human can witness. For a few precious minutes, day turns into twilight. Stars peek out. Birds fall silent. And the Sun reveals a side of itself that is usually hidden behind blinding light. None of that would be visible if the Moon were significantly closer or farther away, a little bigger or a little smaller. The precision of this alignment has led many people in history to see it as a sign, a message, a deliberate design. From a scientific perspective, it is an accident of timing. The Moon is slowly drifting away from Earth each year, and in the far future, total eclipses will no longer occur. We just happen to live in the narrow era where the distances line up perfectly enough to grant us this celestial theater. From a poetic perspective, though, this accident feels like a gift. A brief window during which a young technology-bearing species can look up and glimpse the true structure of its star. Carl Sagan reminded us that we are star stuff, contemplating the stars. When we watch a total eclipse, we become moon stuff, contemplating the Moon as well. For the same ancient rock that once helped life emerge from the seas now allows us to see the Sun's corona and probe the physics of its outer atmosphere. Eclipses have been used to test Einstein's theory of general relativity, to refine our models of solar activity, and to ignite countless hearts with a sense of belonging to something vast and mysterious. From my own perspective, the Earth-Moon system feels like a meditation written in orbits. The distance between the two worlds is a silence that invites reflection, a pause between breaths on the scale of space. To imagine the Moon at its true distance is to allow the sky to stretch wider than our fears and worries, wider than our ambitions, wider than the narrow frames through which we usually view our lives. There is a quiet lesson hidden in that enormous gap. Just as we routinely underestimate the distance to the Moon, we often underestimate the scale of forces that shape our own existence. We see only the immediate events at the surface of life, but not the deep gravitational currents of history, environment, and chance that guide us. The Moon reminds us that what looks close and simple can in fact be distant and complex. That behind familiar appearances there may lie enormous hidden spaces waiting to be understood. When you stand under the night sky and see the Moon rising above the horizon, it glows with a softness that makes everything feel intimate, like a companion that has followed humanity through every chapter of our story. It has watched humans paint on cave walls, plant the first seeds, build cities, and finally launch metal machines to cross the void and touch its dust. In every culture, it has been a symbol of romance, madness, rebirth, and time itself. Yet behind all those myths is a real rock in a real orbit, holding our world steady with invisible hands. From the vantage point of cosmic scale, the Moon is small and Earth is smaller still. but their relationship creates a pocket of stability and wonder in an often indifferent universe. The distance that once felt like an illusion becomes a source of gratitude, because it is precisely that gap that allows the right gravitational pull, the right tidal rhythms, and the right eclipses to exist. So the next time you gaze at the moon and feel that strange mixture of closeness and remoteness, you are sensing something profoundly true. Emotionally, it is near enough to confide in. Scientifically, it is far enough to humble you. In that tension between nearness and distance, our imagination finds room to breathe. Our curiosity finds reason to grow. And our sense of place in the cosmos becomes both smaller and more precious than ever. And as your thoughts drift with that pale companion across the sky, a new question may gently arise within you. If a single moon at this particular distance can shape our tides, our climate, and even our myths so deeply, what other hidden harmonies might be waiting in the wider architecture of the solar system to reveal just how delicately our small world is woven into the fabric of space and time? Have you ever truly asked yourself what it means that almost everything in our solar system belongs to the sun? At first, the question sounds abstract, something for textbooks and diagrams. But when you sit with it in the quiet of your own mind, it becomes almost unsettling. We grow up thinking of the planets as a family of worlds, each with its own personality and story. Yet, in terms of mass and power, the sun is the empire, and everything else is little more than dust. Brian Cox likes to remind us that the solar system is almost entirely empty space, and that the sun holds virtually all of the weight. That simple statement is both a fact and a meditation. Imagine standing on a summer field at noon, feeling the warmth on your skin, watching the light spill across leaves and stone. It feels gentle, almost fragile, something you can hide from by stepping into the shade. Yet that warmth is the diluted breath of a thermonuclear heart so vast that over 1 million Earths could fit inside it. The sun is not just big in some vague sense. It is overwhelmingly dominant. More than 99% of all the mass bound to our star is the star itself. The planets, moons, asteroids and comets together make up only a thin garnish on its gravitational feast. Carl Sagan once said, "We live on a mote of dust suspended in a sunbeam." When you think about the mass of the sun, those words take on another layer of meaning. That sunbeam is not just a pretty metaphor. It is a physical torrent of energy created by the fusion of hydrogen into helium deep in the core. A process that has been burning for billions of years and will continue for billions more. The light that touches your face left the surface of the sun about 8 minutes ago. But before that, it spent tens of thousands of years fighting its way outward from the core through dense layers of plasma, scattering, zigzagging, slowly working its way to freedom. By the time it escapes and races across 93 million miles of space to reach Earth, it has forgotten the long struggle of its birth, arriving as a soft touch of warmth and a golden shimmer on water. Neil deGrasse Tyson often points out that we are bathed in the light of the sun in the most literal possible sense. Every plant that grows, every breath we take, every flame that burns in a fireplace on a winter night is borrowed sunlight stored in chemical bonds, released again into the world. The sun is not just large and heavy. It is the deep origin of almost everything we call life. Yet even with these images, our minds struggle to grasp its magnitude. We are creatures used to comparing houses and mountains, not stars and planetary systems. When someone tells us that the sun is hundreds of thousands of times more massive than Earth, the numbers pile up. but the intuitive feeling lags behind. So perhaps it helps to change the picture. Imagine shrinking the sun down until it is the size of a large glowing lantern hanging in a dark cathedral of space. On that same scale, Earth would be a grain of sand circling far away, and Jupiter would be a small marble, still utterly insignificant compared to the lamp. Most of the cathedral would not be filled with objects at all, but with pure emptiness. A silence so huge that even beams of light seem to take forever to cross it. We talk casually about the speed of light, as if 8 minutes from sun to Earth were nothing. Yet if you could ride on a photon and look back, you would see the sun slowly shrinking behind you as you raced outward, its fiery disk turning into a blinding star, while Earth grows from nothing into a delicate blue arc. Then a full world. You would understand in your bones that distance, even within our local neighborhood, is no trivial thing. But perhaps the most mind-bending part of the solar system is not the familiar zone of planets at all. It is the invisible envelope of icy bodies we call the Oort cloud. Most of the time, when we picture the solar system, we imagine a flat disk with orbits drawn neatly around the Sun. Mercury closest, Neptune at the edge. Beyond Neptune we might remember the Kuiper Belt, home to Pluto and many other frozen worlds. And it is tempting to think that beyond that the solar system simply ends. But the Sun's reach extends much farther. The Oort cloud is a vast spherical shell of ice and rock, made of the ancient leftovers from the birth of the planets. Trillions of frozen fragments drifting so far from the Sun that its light is barely more than a bright star in their black skies. These distant bodies can take millions of years to complete a single orbit, circling the Sun at distances so great that words almost lose their meaning. If we define the true border of the solar system as the region where the Sun's gravity still holds sway more than the pull of the galaxy around us, then that border lies somewhere out in the Oort cloud. That is the invisible frontier where the kingdom of the Sun finally fades into the general ocean of the Milky Way. When I think about this, I find something quietly astonishing. What we call our solar system is not a tidy family portrait of 8 planets. It is a colossal sphere of influence, dominated almost entirely by a single star, wrapped in darkness, dotted here and there with tiny worlds and icy wanderers. We do not live in a clockwork filled with objects at every turn. We live in the faintly lit interior of a gravitational bubble inflated by the mass of the Sun. This realization changes the way I feel about our place here. There is a tenderness in knowing that the warmth of a summer afternoon is the distant echo of a raging stellar furnace, and that the calm of a winter night hides the same relentless energy. There is comfort in seeing that our planet, fragile as it is, belongs to a system that has remained stable for billions of years because of the Sun's overwhelming pull. At the same time, there is a kind of humility that comes from acknowledging how little we contribute to the whole. Earth is not the anchor of anything. It is a passenger, carried along in a celestial current, shaped by a star we neither control nor fully understand. And, yet, that does not make us meaningless. If anything, the Sun's dominance makes our situation even more remarkable. Out of all the tiny grains and frozen shards scattered through this enormous sphere of influence, one small world has managed to become aware of the star that rules it. On that grain, chemistry learned how to sing and write and build telescopes, how to measure light and decode its story. Somewhere in this star-dominated system, a species rose up and said not only, "What is the Sun?" but also, What does it mean that we are here, under it at all? The lesson I draw from this is gentle but powerful. We are not the main characters in the solar system. The sun is. Without it, there would be no orbits, no seasons, no blue sky, no green forest. Without it, Earth would be a frozen stone wandering a lonely path through interstellar night. Recognizing the sun's supremacy does not push us down. It invites us to live in gratitude. Gratitude that we exist in the narrow band of distance where light is gentle enough to nurture, yet strong enough to awaken chemistry into life. Gratitude that our world circles a stable star, rather than an erratic one. There is also a call to responsibility hidden in this awareness. If we are children of the sun, then Earth is the cradle in which its light has woven something rare, perhaps even precious on a galactic scale. To damage that cradle through carelessness or greed is to squander a gift that took billions of years of stellar burning to prepare. Every forest is sun turned into wood. Every breath of oxygen is sun turned into air. Every meal is sun turned into life. So when you walk outside tomorrow and feel the sunlight on your face, you might let yourself remember that you are standing inside the realm of a star that holds almost everything in its grasp. You might imagine the long journey of that light from core to surface to space to your skin, and feel for a moment that you are part of a story much older and larger than any human civilization. In that quiet awareness, the dominance of the sun stops being a dry fact and becomes a kind of cosmic lullaby. A slow, steady assurance that while we are small, we are not lost. We move within the embrace of a star, and as we learn to understand it, we also learn to understand ourselves. And perhaps, as we continue this journey outward through the solar system and beyond, that question will linger as a gentle echo in the background of our thoughts. If one star can command such an enormous kingdom of space, what other wonders await us in the wider empire of the galaxy and the universe beyond? Have you ever looked up at the quiet night sky and wondered whether those nearby stars are really as close as they seem to your eyes? From the ground, the heavens look almost intimate. The constellations appear as patterns drawn just beyond the reach of your hand, and the bright star nearest the moon might feel only a little farther than our own sun. Yet the truth that astronomy uncovers is both unsettling and beautiful. The space between the stars is so enormous that even our fastest spacecraft crawl through it with the slowness of a drifting leaf in a cosmic hurricane. Neil deGrasse Tyson once said that the universe is under no obligation to make sense to us, and nowhere is that more apparent than in the realm of interstellar distance. When we speak of the nearest star to the Sun, Proxima Centauri, the word nearest quietly hides a vast chasm of emptiness. Proxima is roughly 4.2 light-years away, which means that even light, the fastest thing in the universe, takes more than 4 years to travel from there to here. By comparison, sunlight takes just over 8 minutes to reach Earth. Our minds can grasp minutes, but they stumble over years of travel for a single beam of light. Now imagine Voyager 1, a small robot emissary launched in the 1970s, still racing outward at more than 17 kilometers per second. To human intuition, that feels impossibly fast. Yet when you ask how long it would take Voyager 1 to reach Proxima Centauri if it were heading in exactly that direction, the answer stretches beyond the span of recorded history. It would need tens of thousands of years, longer than any civilization has so far endured. By the time it arrived, continents would have shifted. Languages evolved, and the memory of its departure would likely have faded into myth. This is why astrophysicist Brian Cox often emphasizes that the stars you see as close companions in the sky are in fact separated by gulfs of space so vast that each star is almost isolated in its own private bubble of darkness. The Milky Way may look like a glowing river of light, but on the scale of individual stars, it is mostly emptiness punctuated by tiny points of burning matter. It is this emptiness that makes Earth effectively invisible in our local cosmic neighborhood. If an observer were to stand on a planet around Proxima Centauri and look back toward the Sun, they would see a star not unlike the others scattered across their sky. Slightly brighter perhaps, but still just another dot. Earth would disappear completely in that glare, a world lost within a single pixel of stellar light. Even with telescopes far more powerful than those we have today, detecting a small rocky planet like ours across interstellar distances is a delicate and uncertain task. From most nearby systems, our home would not look like a blue marble decorated with clouds and continents. It would not look like anything at all, swallowed by the radiance of its host star. Carl Sagan once described Earth as a mote of dust suspended in a sunbeam. When you extend that image into interstellar space, the dust mote becomes even more fragile. It is not only small, it is drowned in darkness and distance. This is the essence of Earth's interstellar invisibility. Not just that it is tiny, but that the sheer volume of space around it renders it statistically insignificant. The universe is like an ocean so vast that even a continent-sized island would vanish from view a short distance away, and our planet is far smaller than that. Yet there is a quiet paradox hiding here. The more we realize how impossible it is for others to see us, the more we are compelled to ask whether anyone is trying at all. The famous Fermi paradox wraps itself around this question. If the galaxy is so old and so full of stars, where is everybody? One possible answer is brutally simple. The spaces between habitable worlds are so enormous, and the speeds we can achieve are so small compared to light, that civilizations remain forever confined to their own neighborhoods. Even if the galaxy were alive with minds, they might pass through their entire histories without ever seeing one another clearly. In a way, this transforms our sense of loneliness into something gentler and more contemplative. We are not necessarily alone because the universe is empty. We might be alone because the universe is vast, and because the stars are separated by stretches of darkness that swallow most attempts at contact. From a personal perspective, meditating on these interstellar distances feels like sitting beside a silent lake at night, watching faint ripples move across the surface. You know that somewhere on the other shore there may be other beings looking out as you are. Yet the water between you absorbs every whisper. That silence is not hostile. It is simply the natural state of a universe built on the scale of light years rather than kilometers. This understanding reshapes how I see Earth's supposed importance. On a map of nearby stars, our world does not stand out. It does not glow more brightly or occupy a special coordinate. If anything, it is profoundly ordinary. One of many possible planets circling one of many possible suns. But this ordinariness, viewed from another angle, is exactly what makes it extraordinary. Think of it this way. In a galaxy where planets are likely common, the vast majority may be barren rocks, frozen wastelands, gas-shrouded giants with no solid surface. To find even one world where matter has arranged itself into oceans, forests, symphonies, mathematics, and quiet human worries is already astonishing. The fact that such a place is invisible from almost everywhere else does not diminish its value. It enhances its preciousness. When we accept that no one around Proxima Centauri can see our cities, our art, or our sorrow, something shifts inside. Our constant need to be seen, to be recognized, to be applauded by some cosmic audience begins to fade. In its place, a quieter motivation emerges. We choose to live meaningfully, not because the universe is watching, but because we are. Interstellar distances also teach patience. Light itself must commit years to a simple journey between neighboring stars, and any future spacecraft we might build will likely take far longer. In a culture that craves instant results, this cosmic slowness is like a deep breath drawn over centuries, reminding us that not all important journeys can be rushed. There is another lesson hidden in Earth's invisibility from nearby systems, a lesson about humility and responsibility. Because nobody out there can see us clearly, our moral choices are not being scored on some interstellar scoreboard. We are responsible for this world simply because we are the ones who can affect it. Carl Sagan famously said that on that small pixel of light lies everyone you love, everyone you know, everyone you have ever heard of. When you place that pale dot against the backdrop of interstellar space, it becomes obvious that if we do not care for this world, there is no guarantee that anyone else will. So when I think of Voyager 1 streaming away from the sun, carrying its golden record of sounds and images of Earth, I do not imagine it as a serious attempt at conversation with distant civilizations. Instead, I see it as a message we wrote for ourselves. A quiet reminder that even if nobody ever finds it, we once cared enough to say, this is who we were, on this small world no one could see. In a meditative sense, contemplating interstellar space invites us to release the tight grip of ego and rest in a wider awareness. The stars near the sun are unimaginably far, and between them our planet slips like a soft note in a vast symphony that few ears will ever hear. Yet the music still matters, because we are the ones hearing it. As you listen to these thoughts, you might imagine yourself floating just beyond the solar system, watching the sun shrink into a bright star among many, knowing that somewhere in that tiny beam of light orbits a planet that holds your entire life. You cannot see it, but you know it is there, fragile, luminous, temporary. And perhaps, as this image settles into your mind like a slow-turning galaxy, a final question will arise. If Earth is almost invisible even to our closest stellar neighbors, how might this understanding change the way we live together on this hidden world? Knowing that in the grand quiet of interstellar space, we mostly only have each other to see. Have you ever wondered what it really means when astronomers say that some stars are so huge they could swallow our entire solar system? At first, the words sound like exaggeration, poetic language rather than sober science. Yet the more we look up and measure, the more we are forced to accept a quiet and unsettling truth. The universe has created objects so enormous that even our sun looks modest beside them. And compared to those giants, Earth is barely more than a whisper of matter. We begin with something deceptively small, the red dwarf star. If you could place a typical red dwarf next to our sun, you might say it looks like a glowing ember beside a bright campfire. Its light is faint, its temperature lower, its radius only a fraction of the Sun. And yet, if we place Earth beside that so-called small star, the comparison is no longer gentle. Earth shrinks into the scale of a grain of dust hovering near a glowing planet-sized sphere of fire. Even the smallest stable stars barely massive enough to ignite hydrogen in their cores, are still dozens of times wider than our planet and many thousands of times more massive. The numbers themselves are far less important than the feeling they awaken. Our everyday intuition about size belongs to a world of trees and houses and mountains, not to a realm where even the most modest objects can weigh more than all the planets put together. As physicist Brian Cox often explains, stars are not simply bigger versions of familiar things. They are different categories of existence entirely. When we move from red dwarfs to stars like the Sun, the scale shifts again. Our Sun is a main sequence star, steady and middle-aged, shining quietly for billions of years. It would take over 100 Earths lined up edge to edge to span its diameter, and about 1 million Earths to fill its interior if you could pack them efficiently like marbles in a sphere. Already, at this stage, Earth is pushed into the background of cosmic architecture. It is not the protagonist, it is a detail. But even the Sun is just a starting point in the grand zoo of stellar sizes. As stars grow more massive, their structure changes, their atmospheres swell, and their outer layers balloon outward to forms that challenge and then break our sense of proportion. We encounter red giants, then red supergiants, titans whose outer edges can stretch beyond the orbit of Earth, sometimes beyond the orbit of Jupiter. Consider a star like Betelgeuse in the constellation Orion, a red supergiant whose very name now carries the flavor of myth. If you were to replace our Sun with Betelgeuse, its swollen atmosphere would engulf Mercury, Venus, and Earth, and quite possibly reach Mars. The orbit where our planet now travels would lie deep inside the star itself. In such a scenario, not only would Earth be small, it would be erased. And even Betelgeuse is not the limit. There are record-holding giants like Scuti, a star so vast that analogies begin to sound like legends told around a cosmic fire. If Scuti sat where our Sun is now, its radius would extend far beyond the orbit of Jupiter, maybe even approaching Saturn. Hundreds of millions of Earths could fit inside its volume. Not 100, not 1,000. But numbers so large that language begins to fray at the edges when we try to make sense of them. Astrophysicist Neil deGrasse Tyson reminds us that the universe is under no obligation to match our expectations. Our minds are wired for modest scales, but stars show us what happens when nature is allowed to follow its equations without restraint. Pressures soar, temperatures spike. Hydrogen fuses into helium and heavier elements in roaring nuclear furnaces. In that extreme environment, a star can grow into a thing so enormous that any planet nearby becomes an afterthought. Even at the bottom of the stellar scale, near the borderline between proper stars and failed stars known as brown dwarfs, the story is similar. These objects may be only slightly larger than Jupiter in radius, yet they still outweigh Earth by factors of hundreds or thousands. Gravity gathers matter with ruthless efficiency, shaping it into spheres of dense plasma or compressed gas, and what we call small or large stops being helpful language. From a human perspective, we might imagine Earth as a grand stage on which history unfolds. But from the point of view of a massive star, our planet is closer to a dust mote drifting in the glow of a nearby bonfire. When we see diagrams showing Earth as a tiny dot, beside stars like Scuti, it is easy to think they are exaggerated for dramatic effect. The reality is often the opposite. The diagrams usually soften the contrast so that our eyes can still register both objects on the same page. Carl Sagan once said that somewhere something incredible is waiting to be known. Part of that incredibleness lies in how thoroughly the universe defies our sense of proportion. We grew up beneath a single star, our sun, and even that star we rarely see as more than a bright disk in the sky that warms our days. Only when we compare it to other stars do we begin to appreciate just how wild the range of possibilities truly is. From my own point of view, contemplating this diversity in stellar size feels a bit like sitting beside an endless river at night, watching reflections of distant fires drift past on the surface. Some glows are faint, flickering quietly, like red dwarfs with their long, calm lives. Others flare bright and brief, like the massive blue stars that rush through their fuel and die in spectacular supernovae. A few are so enormous in memory and concept that they feel less like stars and more like temporary universes unto themselves. In that gentle darkness, Earth becomes not a center but a shoreline, a narrow strip of sand from which we watch cosmic tides roll by. There is a quiet lesson hidden inside these comparisons. If we judge importance by size alone, then Earth and everything on it barely deserves a footnote. But we do not live meaningfully in units of kilometers or solar radii. We live in units of experience, of consciousness, of stories told and feelings shared. A giant star may blaze with power, but as far as we know, it does not sit in the night and wonder what it is. It does not ask about its own origin. It does not marvel at the fact that it exists at all. On this tiny world, orbiting an average star in the outskirts of a typical galaxy, something rare is happening. Matter has arranged itself not only into mountains and oceans, but into living beings who can feel awe when they look at those mountains and oceans and then extend that awe outward to the stars themselves. In that sense, Earth may be small in volume, but it is vast in the dimension that may matter most: the capacity to host awareness. When we listen to the calm voice of the cosmos, it does not say grow larger. It says become deeper. Deeper in understanding, deeper in compassion, deeper in curiosity. The diversity of stellar sizes invites us not to envy the giants, but to appreciate the miracle of being small and yet able to comprehend what a giant is. So as you imagine red dwarfs glowing gently for trillions of years, red supergiants swelling to impossible diameters, and titans like Scuti standing as monuments of light against the dark, allow a simple image to remain in your mind. A pale blue world, fragile and finite, carrying oceans and forests and cities and quiet rooms where someone lies awake at night wondering about their place in all of this. In that image, the stars are no longer just distant suns. They are luminous teachers, showing us the extremes of what nature can build, and by contrast, revealing how precious it is to exist as a small, thinking creature with the ability to look up and feel both humbled and comforted at the same time. And perhaps, as you drift towards sleep under the shared sky, you might carry one last gentle question with you. If the universe can craft such immense blazing giants out of simple hydrogen, what quiet masterpieces might it be shaping within the tiny space of a human heart when that heart dares to wonder about the stars? Have you ever wondered where we truly live inside the Milky Way? Not just our street or our city, but our real address in the galaxy. From the ground, the night sky feels like a roof sprinkled with lights, a flat pattern stretching above us. But the truth is far stranger and far more beautiful. We are not simply under the Milky Way. We are inside it, embedded in one of its spiral arms, drifting through space on a tiny island of rock and air that almost completely disappears when measured against the scale of the galaxy. Astronomer Carl Sagan once said that our galaxy is a kind of city of stars, a great metropolis in which our sun is just one faint street lamp among hundreds of billions of others. Brian Cox often puts it even more bluntly, reminding us that we live on a small planet orbiting a star on the outskirts of a typical spiral galaxy in a universe filled with galaxies. It is a way of saying that there is nothing central or privileged about our position, at least not in terms of size or placement. And yet, when we look closer, the outskirts may be precisely what make our existence possible. Imagine first the Milky Way as a vast rotating disk of stars, gas, dust, and dark matter, about 100,000 light-years across. In the bright central bulge, stars crowd together in dense swarms, orbiting the hidden mass of a supermassive black hole named Sagittarius A*. The inner regions are violent and luminous, saturated with radiation and gravitational chaos. Farther out, the galaxy relaxes into graceful spiral arms, and somewhere along one modest arm, called the Orion Arm, about 27,000 light-years from the center, our sun quietly turns. If you could hold a miniature model of the Milky Way in your hands, perhaps the size of a large city, our entire solar system would be far too small to see. Even if you marked the location of the sun with a tiny pinprick, Earth would be invisible, a fraction of a speck. On the galactic map, our world is not merely small, it is effectively absent. Yet, on that invisible point, oceans rise and fall, forests breathe, civilizations build telescopes and whisper questions into the dark. The timescale of the galaxy also stretches beyond every ordinary intuition. One orbit of the sun around the galactic center, sometimes called a galactic year, takes about 225 million of our familiar Earth years. That means that since the age of the dinosaurs, the solar system has barely completed a single lap around the galaxy. Human history, with all its empires and revolutions, occupies only a tiny fraction of a single degree along that orbital path. When you walk outside and feel the ground beneath your feet, you are standing on a moving platform that is both spinning daily, orbiting the sun yearly, and at the same time, drifting on a vast spiral route around the heart of the Milky Way. Neil deGrasse Tyson likes to point out that we are participants in this grand motion, whether we are aware of it or not. We are passengers on a starship called the Solar System, sailing through the galaxy. Yet there is something wonderfully ironic here. For all this motion, for all this immense journey through space and time, our best chance to exist as complex, fragile beings may depend on staying very far away from the galaxy's busiest neighborhoods. The central regions of the Milky Way might look stunning in an artistic visualization, glowing with dense star fields and radiant clouds of gas. But to life as we know it, they would be dangerous. Frequent supernova explosions, intense gamma-ray bursts, strong tidal gravitational fields, and high levels of radiation would continuously threaten the stability of planetary atmospheres and biospheres. Close encounters between stars could disturb planetary orbits, either freezing worlds in the cold or hurling them into their suns. In such an environment, the chemical seeds of life might form, but its long, patient unfolding into complex organisms would face constant interruption. The outermost edges of the galaxy, on the other hand, may be too quiet and too poor in heavy elements. The early universe contained mostly hydrogen and helium, and it took generations of stars living and dying to forge heavier elements like carbon, oxygen, iron, and all the atoms that build planets, oceans, and bodies. If you go too far into the galactic outskirts, you may find stars with very few of these ingredients. Lonely suns whose planets, if they exist at all, might be barren and simple. Our solar system appears to inhabit a kind of golden compromise, not too close to the violent heart, not too far into the resource-poor halo, orbiting in a region often called the galactic habitable zone. It is an idea still being refined and debated by astrophysicists, but it carries a poetic resonance. Just as Earth sits at a distance from the Sun that allows liquid water to persist, avoiding both the furnace and the deep freeze, so the solar system may sit within the Milky Way at a distance that balances safety and richness, protection and possibility. From this vantage, Earth truly disappears in size, but in another sense it becomes even more remarkable. Out of an entire galaxy of stars, we occupy a thin, quiet lane where the background radiation is relatively mild, where stellar encounters are rare, where there has been enough time for life to climb from molecules to minds without being reset by catastrophic events too often. As physicist Freeman Dyson once mused, the more we learn about the universe, the more it seems that the universe knew we were coming. We do not need to take that literally, but we can feel its emotional weight. Our address in the galaxy, though ordinary on a map, is exquisitely tuned for the possibility of beings who can wonder about it. Personally, when I meditate on our place in the Milky Way, I feel a strange blend of humility and belonging. Humility, because our planet fades so quickly as we zoom out that it almost feels like an illusion. Belonging, because that same tiny place is perfectly embedded in a cosmic structure that has allowed us to arise at all. It is as if we are living in a quiet suburb of a vast, luminous city, far from the noise of the center, but still well connected to its lifeblood. We are not in the spotlight, and that is exactly why we can survive long enough to light our own small lamps. There is a lesson hidden inside this galactic perspective. On Earth, we argue about borders, compete for territory, and cling to identities as if they were fixed and absolute. But from the point of view of the Milky Way, all of humanity shares the same incredibly specific and fragile coordinates. We are all, regardless of language or nation, residents of the same narrow band of the Orion Arm, circling the same galactic center in slow, patient silence. The galaxy does not recognize the lines we draw on maps. It only knows the physics of orbits, the flow of gas, the birth and death of stars, To remember this is to feel a softening inside. The conflicts that fill our news cycles are real and painful, but they are also small compared to the vast and ancient journey we are taking together. Each of us is a brief flicker of awareness riding on an orbit that will last hundreds of millions of years. We will not complete the loop. Our species, if it endures, may see many galactic years come and go, but each individual life is a brief shimmer along that path. This need not make us feel insignificant. Instead, it can inspire us to live more gently, more thoughtfully, more in tune with the rare and precious conditions that allow us to be here at all. In quiet moments, you can imagine the view from far above the Milky Way, seeing its spiral arms curl through the dark, watching the slow rotation of that glowing disk. Somewhere out in one of those arms, too small to see but not too small to matter, lies a pale world with oceans and clouds, with forests and songs, with minds that can lift themselves beyond their daily concerns and whisper into the night, asking where they truly are. In that whisper, the galaxy hears its own structure, reflected back as curiosity. So when we ask about the Milky Way and our true position within it, we are not just satisfying a scientific curiosity. We are engaging in a kind of cosmic self-awareness on behalf of our tiny corner of space. We are acknowledging that we live on a world that disappears on the galactic scale, orbiting on a time cycle so vast that it stretches the concept of a year beyond recognition, settled in an outer region whose very safety has quietly nurtured our existence. And in recognizing this, we discover a gentle but powerful truth. We may be small and peripheral, but we are also, for now, wonderfully and improbably alive. The next time you step outside on a clear night and see the hazy band of the Milky Way arching overhead, you might remember that you are not just looking at your galaxy. You are looking along the plane of your own home disk, staring through billions of stars that share your orbit around the same unseen center. Somewhere in that vast wheel of light, hidden in a quiet spiral arm, is the tiny point from which you gaze. To feel that, deeply and calmly, is to let science become a kind of meditation, and to let the galaxy itself cradle you in its slow and endless turning. Have you ever wondered if our Milky Way is just another anonymous light in the dark, or if it holds some secret role in the vast city of galaxies? From the ground we see only a pale river of stars stretched across the night sky, fragile and misty, like someone spilled milk across velvet. But the moment we step back in our imagination, we realize that this soft band is really the inside view of an entire galaxy, a spinning island of hundreds of billions of suns. And then a deeper question rises quietly beneath it all. If even our galaxy is only one among countless others, what does that say about our true place in the universe? Edwin Hubble once looked through a telescope and discovered that what people thought were little clouds were in fact entire galaxies far beyond the Milky Way. In a single human lifetime, the universe expanded not in size but in meaning, from one galaxy to a cosmos filled with them. Today we know that the Milky Way is not a grand exception. It is a kind of middle child, an ordinary spiral galaxy living in a modest neighborhood called the local group. This group is a small collection of a few dozen galaxies, dominated by three majors: the Milky Way, Andromeda, and the Triangulum Galaxy. If you could step outside this structure and watch it unfold over billions of years, you would see the galaxies moving like slow dancers in a silent ballet of gravity. Andromeda is drifting towards us, and in several billion years, the Milky Way and Andromeda will merge into a single larger galaxy, sometimes called Milkomeda in playful models. Brian Cox often says that we are witnessing the universe in a state of continuous change, where every galaxy has a history and a future written by gravity. This future collision is not a rare accident. It is a normal step in the life of galaxies. Beyond the local group lies a grander structure called the Virgo cluster. If the local group is a small town, then the Virgo cluster is a massive metropolis of galaxies, containing thousands of them bound together in a deep shared gravitational well. At its heart sits M87, a giant elliptical galaxy so massive that it dwarfs the Milky Way. M87 is home to a supermassive black hole that humanity has actually glimpsed using the Event Horizon Telescope, a dark shadow encircled by glowing gas. This image is not just a scientific milestone. It is a poetic reminder that at the center of some galaxies lie monsters made of pure gravity, shaping the motion of stars on scales we can barely imagine. When we zoom out again, even the Virgo cluster is not alone. It is part of something larger called the Virgo supercluster. And even that, according to modern maps of the universe, is woven into an even greater structure called Laniakea, which in Hawaiian means immeasurable heaven. The Milky Way, our familiar spiral with its quiet arms and shining core, is just a tiny filament inside this titanic gravitational basin. When you say the word galaxy, you might think of a single island of stars. But the universe arranges these islands into groups, then clusters, then superclusters, and then into a cosmic web that stretches like threads of light across an almost unimaginable volume of space. Carl Sagan once said that ours is a small galaxy, lost somewhere between two great clusters of galaxies, and that we are adrift in the great ocean of space. His words feel almost like a lullaby for the cosmic soul, at once humbling and strangely comforting. The more we learn about how galaxies and clusters form, the more we see a simple story told on enormous scales. In the early universe, tiny fluctuations in the density of matter served as seeds. Regions slightly denser than average pulled in more matter, grew heavier, and collapsed into halos where gas cooled and gave birth to stars. Those halos merged with others, forming larger and larger structures. Over billions of years, the universe became a dynamic landscape of merging galaxies, cannibalistic giants swallowing their smaller neighbors, and clusters forming at the intersections of the cosmic web. M87 and other giant ellipticals we see today are like the elder citizens of this cosmic city, built out of dozens or hundreds of smaller galaxies consumed long ago. Their smooth shapes hide violent histories, like a calm face that once weathered many storms. In this grand architecture, the Milky Way is neither a palace nor a slum. It is a comfortable home in a decent neighborhood. Not too crowded, not too isolated. From a scientific perspective, this is more than poetic coincidence. Some researchers believe that being in a relatively quiet region of a relatively average galaxy may have been important for complex life to arise. Too close to the crowded core and the radiation and frequent supernovae might sterilize nascent biospheres. Too far in the lonely outskirts, and there might not be enough heavy elements to build rocky planets at all. When I think about galaxy groups and clusters, I see not just structures, but relationships. Every galaxy in the local group feels like a neighbor, Andromeda, the looming friend we will one day embrace. The smaller dwarf galaxies like quiet villages that orbit in loyalty around larger cities. Gravity is the invisible thread that binds them, weaving their individual stories into a shared destiny. There is a lesson here for us, whispered gently through the language of cosmic structure. Just as galaxies rarely travel alone, neither do we. Communities form, families gather, nations cluster, and even though conflicts divide us, we are ultimately bound together on the same world, orbiting the same star. In the same way that galaxies feel the pull of their group, we feel the pull of connection, memory, and shared experience. Vera Rubin, the astronomer whose work revealed the presence of dark matter in galaxies, once said that science is telling us we are more connected to the universe than we ever imagined. Her discovery showed that most of the mass holding galaxies and clusters together is invisible, unseen stuff that does not shine but shapes everything. In a strangely poetic way, this is true of human life as well. There are invisible forces binding us: love, trust, curiosity, that hold communities together just as dark matter holds galaxies together. Thinking about the Virgo cluster and the Virgo supercluster, I often feel as though we live inside the pages of a book too large to finish. Every galaxy is a chapter, every cluster a volume, every supercluster a library. The local group is only one sentence in that library, and yet for us, it is the entire story we can reach. This contrast between our small reach and the universe's vast structure can feel overwhelming, but it can also be deeply calming. Because if the universe can take tiny quantum fluctuations and patiently grow them into galaxies and superclusters over billions of years, then perhaps we do not need to rush so desperately through our short human lives. We can move more slowly, breathe more deeply, allow ourselves to be works in progress. The cosmic web was not woven in a day, and neither are we. In the end, the story of other galaxies, of the local group, of the Virgo cluster and Virgo supercluster, is a story about context. The Milky Way is not alone. It is one thread in a tapestry of unimaginable scale. Our home galaxy flows along the gravitational currents of Laniakea, and somewhere deep within one of its spiral arms, on a small rocky world wrapped in a thin veil of air, a species has just begun to open its eyes. From this gentle viewpoint, the lesson becomes clear. We are tiny, yes, but we are also exquisitely placed within a living universe of structure and relation. To know that the Milky Way is just one galaxy in a group, inside a cluster, inside a supercluster, is not to feel lost. It is to realize that we belong to something vast and beautiful. And as you let this sink in, perhaps while drifting towards sleep, under a quiet sky, you might feel a new kind of peace spreading through you. The peace of understanding that we are small, connected, and gently carried along within the immense and intricate community of galaxies that fills the dark. Have you ever imagined that behind the scattered stars we see in the night sky, there is a hidden web so vast that our entire galaxy is just a faint thread in its design? When we first learn about the universe, we often start with planets, then stars, then galaxies. Each step feels like a revelation. Each new layer seems unimaginably large. But there is a level of structure beyond galaxies, beyond clusters, where the universe stops looking like a simple collection of islands of light and starts to resemble something organic, almost like a living nervous system stretched across billions of light years. This is the cosmic web. Cosmologists have spent decades mapping this web, tracing how gravity and dark matter sculpt filaments of galaxies that stretch like luminous rivers through space. In that grand cartography, our home is inside a structure we call Laniakea supercluster, a Hawaiian word meaning immeasurable heaven. It is a fitting name, because within Laniakea, more than 100,000 galaxies drift together in a slow, majestic ballet guided by gravity and the invisible skeleton of dark matter. The Milky Way is only one small swirl of light inside this ocean of worlds. Brian Cox often says that when you look at the largest scales, the universe begins to look less like a random cloud of galaxies and more like a structure with pattern and flow. Laniakea is one of those places where pattern becomes visible. Our galaxy is not moving randomly. It is being drawn, along with its neighbors, by a gravitational current toward a mysterious region known as the Great Attractor. The name itself sounds dramatic, almost poetic, but it is simply our way of acknowledging that there is a region of space where so much mass has gathered that entire clusters of galaxies fall toward it like leaves caught in a cosmic river. For a long time, we could not even see this region clearly because it lies behind the dense plane of our own galaxy, hidden by dust and stars. Yet we can feel its pull in the motions of hundreds of galaxies, including our own. And even beyond the Great Attractor, there is an even larger concentration of matter called the Shapley supercluster, a titanic assembly of clusters that tugs on Laniakea itself. It is as if our entire supercluster is just one small boat being drawn downstream by currents that originate far beyond our immediate cosmic neighborhood. When we speak of these structures, numbers quickly lose their emotional weight. Hundreds of millions of light years, quadrillions of suns. They sound like abstract exaggerations, but the feeling they evoke can be more subtle and more profound. A quiet recognition that our familiar Milky Way is not a grand central city of the cosmos, but a modest town on the outskirts of a supercontinent of galaxies. And even that supercontinent is not the whole story. Beyond clusters and superclusters, astronomers have discovered structures called Great Walls, enormous chains of galaxies stretching across a significant fraction of the observable universe. The Sloan Great Wall, mapped using vast redshift surveys, is one such feature, a colossal ridge of matter that extends for over 1 billion light years. Then there is the Hercules Corona Borealis Great Wall, an even more gigantic arrangement of galaxies and gamma-ray burst sources that challenges our ideas of how uniform the universe is allowed to be on the largest scales. When we place these names side by side, Laniakea, Great Attractor, Shapley Supercluster, Sloan Great Wall, Hercules Corona Borealis Great Wall, they can sound like chapters from a mythological epic. Yet each is a real, measurable concentration of matter, an actual feature in the grand anatomy of the universe. And here, something almost paradoxical appears. On these scales, galaxies are the grains of sand, not the beaches. Clusters are not the continents, but the rocks along the shore. Our solar system does not even qualify as a grain. It is more like a speck of dust floating between grains. Earth itself, with all its mountains and oceans, with all its histories and dreams, is so small compared to these structures that it ceases to have any geometric meaning at all. Neil deGrasse Tyson once remarked that we are part of a universe that is not only bigger than we imagine, it is bigger than we can imagine. The cosmic web makes this clear in a way few other ideas can. When we look at computer simulations of the universe, where billions of particles of dark matter and gas evolve under gravity, something hauntingly beautiful emerges. A network of filaments and nodes, so intricate that it could be mistaken for the wiring of a colossal brain. In that brain, every galaxy is a neuron. Every cluster is a luminous knot where information and matter converge. But a brain is not only made of neurons, it is also made of the spaces between them. In the universe, those spaces are called voids. Cosmic voids are vast regions containing far fewer galaxies than average, sometimes almost none at all. They occupy roughly 80% of the volume of the universe, meaning that most of space is not filled with galaxies, but with almost pure emptiness. The structures we find most dazzling, walls, filaments, clusters, are like the thin frost patterns on a window, beautiful, complex, but incredibly delicate compared to the vast transparency that surrounds them. From the perspective of size, Earth does not simply become small here. It becomes effectively irrelevant. There is no map of the cosmic web on which you could mark our planet, no scale at which its contour would appear. Even the Milky Way itself is nothing more than a whisper of light along a single filament of Laniakea. And even Laniakea is merely one region among many inside a network that may span the entire observable universe. When I contemplate this, I feel a mixture of awe and calm. Awe because the architecture of the universe is grand beyond poetry. Calm because it gently dissolves the illusion that everything revolves around us. In the quiet of that realization, the ego begins to loosen. The noise of everyday conflicts lowers to a faint murmur. Arguments about borders, pride, status, all those human constructions suddenly look like small patterns in the sand on a single shore of a single world, soon to be erased by the next cosmic tide. Yet this perspective does not make us meaningless. Carl Sagan reminded us that we are a way for the cosmos to know itself. On the scale of the cosmic web, Earth indeed vanishes as a point in space, but it does not vanish as a point in meaning. Inside this tiny nook of a vast supercluster, matter has arranged itself into oceans and forests, into eyes that can see, into minds that can wonder about Laniakea and the Great Attractor and the lonely depths of the voids. This is where the scientific image of the cosmic web becomes something like a meditation. The filaments of galaxies are vast beyond comprehension, but the awareness that contemplates them is here, now, resting in a fragile body on a small world. Between the immeasurable heaven of Laniakea and the simple act of breathing in the dark room where you listen to these words, there is a bridge of understanding, a quiet recognition that you are both insignificant and deeply connected. From my own point of view, the lesson hidden in these colossal structures is not that we are nothing, but that we are free to choose what kind of something we want to be. If the universe can form great walls of galaxies stretching across billions of light years, then surely, within the much smaller space of a human life, there is room to build kindness, curiosity, and wisdom. The cosmic web reminds me that clinging too tightly to the small dramas of the day is like obsessing over a single grain of dust on a map that spans the entire sky. Instead, we can let that map soften our hearts. We can look at others and remember that they share this tiny dot with us, drifting together through a supercluster we did not choose, carried by gravitational rivers toward destinations we may never fully understand. In that shared drift, empathy becomes more natural than indifference. So yes, on the scale of Laniakea, of the Great Attractor, of the Shapley supercluster, of the Sloan and Hercules Corona Borealis Great Walls, Earth loses all geometric meaning. But in the quiet of your own awareness, as you imagine these titanic structures stretching through the dark, you may notice something gentle arising, a feeling that you are part of a story far larger than yourself. And from within that feeling, another question slowly unfolds. If the universe can weave such a magnificent web from simple laws and silent matter, what new patterns of understanding and compassion might we weave within our brief, luminous moment on this almost invisible world? What if the universe we see is only a tiny circle of light floating inside a much vaster darkness? A lantern, glowing in an endless night that stretches far beyond anything our eyes or instruments can reach. What if the 93 billion light-years we often quote as the size of the observable universe are not a boundary at all, but merely the distance our small patch of space-time has allowed us to witness since the first light began its journey 13,800,000,000 years ago? When we ask how big the universe truly is, we are really asking a question that touches the edge of philosophy, physics, and the quiet chambers of the human mind where wonder is born. Carl Sagan once said that we live on a mote of dust suspended in a sunbeam. And if that mote seems small within the Milky Way, then imagine how dramatically it shrinks when placed inside a universe containing perhaps 2 trillion galaxies. But even that staggering number only describes the part we can see. A sphere drawn not by cosmic architecture but by the simple fact that light has a speed and time has a beginning. To understand the observable universe is to step into a contemplative space where the limits of sight and the limits of existence blur into one another like colors blending in a nebula. The galaxies at the farthest edges of our view are not merely distant, they are ancient. Their light began traveling toward us long before Earth existed, long before the sun was born, long before atoms in our bodies had cooled from the furnaces of dying stars. When we look outward, we look backward. And yet, the strange twist of cosmic expansion means that even though we see a galaxy as it was billions of years ago, the place where that galaxy actually is today might lie much farther away. Space has stretched like a slow breath of the cosmos, lengthening the path between now and then, expanding the darkness. Brian Greene described this beautifully when he wrote that the universe is not only expanding, it is carrying galaxies away from one another as if they were boats drifting on a rising tide. This means the observable universe is not a static bubble, but a growing one, with its edge defined by the race between the speed of light and the speed of cosmic expansion. The moment we understand this, a profound shift ripples through the mind. We begin to realize that 93 billion light-years is not the size of the universe. It is simply the region from which information has reached us. Beyond that, the universe may continue indefinitely, perhaps forever. And once this door is open, another question drifts softly in. If the universe could be infinite, what does infinite even mean for beings who evolved to measure life in footsteps and heartbeats? Astronomer Lawrence Krauss once said that the universe is far stranger than we can imagine, but perhaps not stranger than we can learn to imagine. With each telescope we build, each theory we refine, each simulation we run on powerful computers, the horizon of our understanding expands just a little more. But always, it seems, the universe remains at least one step ahead. Beyond the observable region lies a realm that no photon has ever crossed to reach us. Not because the galaxies there do not exist, but because their light has not had enough time to arrive, or because the space between us and them is expanding faster than light can travel. That expansion does not violate physics, for nothing is moving through space faster than light. Rather, space itself is stretching. Imagine dots painted on a balloon as it inflates. None of the dots move by themselves, yet all grow farther apart. In this simple image lies the first hint that the true universe might be vastly larger than the portion we can see. Perhaps hundreds or thousands of times larger. Perhaps infinite in all directions. And then, like a new star igniting in the darkness, enters the idea of the multiverse. A word that has drifted from scientific speculation into popular imagination. Sometimes misunderstood, sometimes exaggerated. But at its core, the multiverse is simply the recognition that our universe might not be the only one produced by the laws of physics. Inflation theory, proposed by physicist Alan Guth, suggests that the universe underwent a brief and furious expansion a moment after its birth. In some versions of this theory, inflation never fully ends. Instead, it continues in other regions, spawning countless bubble universes. Each bubble may have different physical constants, different histories, perhaps different geometries of space-time. We inhabit just one bubble, unremarkable in position, yet extraordinary in its capacity to generate life. Then there is the many worlds interpretation of quantum mechanics proposed by Hugh Everett. In this view, every quantum event that could happen does happen, branching reality into an unimaginable number of parallel histories. While this idea is not about spatial universes but about superposed possibilities, it deepens our sense that reality might not be singular. As Stephen Hawking once suggested, the universe could be like a giant book, with many chapters we will never read. When we drift into these ideas, something inside the mind loosens, as if the boundaries of thought have been stretched like the fabric of space itself. Suddenly, the observable universe becomes not an end, but a beginning. Not a limit, but a first window into an immeasurable beyond. I often find myself reflecting on what it means to live inside a universe whose true size may exceed comprehension. There is a calm that rises from this reflection, a feeling similar to sitting beside the ocean at night, listening to waves you cannot see crashing far beyond the shore. The vastness does not drown us. It humbles us. It teaches us that understanding is not a possession but a journey, one step at a time. The lesson becomes even more profound when paired with our place in this cosmic picture. Earth is minuscule compared to galaxies. Galaxies are tiny compared to clusters. Clusters are motes compared to the cosmic web. And yet, consciousness has arisen here, on this world, in this fragile sliver of space-time. The universe might be infinite, but awareness within it is rare, perhaps precious. Perhaps the very act of wondering about the universe is the universe learning to wonder about itself. As I let these thoughts settle, I find a quiet reassurance weaving through them like a thread of starlight. even if the universe is boundless, even if countless other universes exist beyond our ability to ever touch, what we have here, on this small world, is enough to fill a lifetime with awe. Because meaning is not measured in light years, but in awareness. Not in the size of the cosmos, but in the depth with which we experience it. And so, as we reach the edge of what we can observe, another gentle question rises like dawn over a dark horizon. If the observable universe is only the first circle of light around our campfire, then what wonders lie in the forest beyond? What if in this entire silent ocean of galaxies, there is only one small place where the universe can sit quietly and ask itself why it exists at all? When we talk about the size of Earth in the cosmos, we usually speak in numbers, in light years and diameters, in ratios that shrink our planet down to almost nothing. Yet the most unsettling truth is not about size at all. It is about meaning. We live on a world that is cosmically insignificant in scale, and at the same time possibly unique in something infinitely precious: the presence of life and the quiet flame of consciousness. Carl Sagan said that we are a way for the cosmos to know itself. And in that single line he gave Earth a role that no equation can fully capture. The origin of life on this little world remains one of the deepest mysteries we face. Somewhere in the ancient oceans, chemistry learned to breathe, molecules learned to copy themselves, and what was once only matter began to carry memory. We do not yet know whether this was an almost impossible accident or a natural step that happens wherever conditions are right. And in that uncertainty lies a quiet tension that runs through all of modern cosmology. If life is common, the universe may be filled with minds that wonder as we do, scattered like lanterns across the dark. If life is rare, then this small blue world might be one of the very few places where atoms have arranged themselves into questions. The idea that intelligent life could be extremely rare is at the heart of the Fermi paradox. Given the age and size of the galaxy, given the sheer number of stars and planets, we might expect the night sky to be buzzing with obvious signs of other civilizations. And yet, as Enrico Fermi famously asked during a casual conversation at lunch, where is everybody? We listen, we scan, we send out weak radio whispers into the dark, and in return we receive only the cosmic background noise of a universe that seems indifferent. There are many possible answers to this silence. Perhaps intelligent life is common but short-lived, burning out in self-inflicted catastrophes before it learns to travel between the stars. Perhaps technological species choose not to broadcast their existence, or communicate in ways we do not yet understand. Or perhaps, and this is both unsettling and awe-inspiring, intelligence is so rare that in our region of space we might truly be alone for a long time. If that is even remotely true, then the philosophical weight on this tiny world becomes almost unbearable. Neil deGrasse Tyson likes to say that we are stardust, with atoms forged in the hearts of long-dead stars. Yet we are not only made of stars, we are the part of the stars that has learned to care, to worry, to hope, to love, to fear the future and to dream of something better. From a purely physical perspective, Earth is negligible. The volume it occupies is almost zero compared to the observable universe. But from the perspective of meaning, it may be one of the rare coordinates where the universe wakes up and looks around. If consciousness truly blooms only in a few fragile places, then every thought you have ever had, every feeling that has ever passed through a human heart, is part of a very small and very delicate experiment being run in a cold and vast arena. For me, this realization carries two currents at once, one humbling, one elevating. On the one hand, we are clearly not the center of the universe, not in position, not in scale, not in power. The sun does not rise for us. It rises because Earth rotates. The galaxy does not care about our borders, our arguments, our pride. As Richard Feynman once remarked, nature cannot be fooled. It obeys its laws with complete indifference to our stories. On the other hand, we might be part of something astonishing. If the cosmos is largely silent, if minds are rare, then our existence as a thinking, feeling species gives us a responsibility that stretches beyond culture and history. We become not just citizens of nations, but caretakers of the only known archive of cosmic self-awareness. The libraries we build, the music we compose, the scientific laws we uncover, all of these are ways in which the universe records its own discoveries about itself. There is also the question of time. Earth will not last forever, nor will the sun. In a few billion years, our star will swell into a red giant, and the gentle conditions that cradle life here will vanish. Long before that, climate shifts, asteroid impacts, or our own technological missteps could end the chapter of intelligent life on this planet. From a cosmic perspective, we exist inside a narrow window, like a single breath taken between two vast silences. Thinking about this future can be frightening, but it can also be clarifying. If we truly are one of the few conscious species in the galaxy, or possibly the only one for a very long distance, then preserving and deepening this flame of awareness becomes more than a matter of survival. It becomes almost sacred. The choices we make about our technology, our environment, and our treatment of one another are not just human decisions. They are moves in a game that may have very few players. My own view is that the smallness of Earth does not diminish us. It refines us. It strips away the illusion that we are grand because we are big, and invites us to seek a different kind of greatness. Greatness not in dominance, but in understanding, not in conquest, but in compassion. When you recognize that every conscious mind may be a rare and fragile emergent property of the universe, cruelty begins to look like a form of cosmic vandalism, the breaking of something exquisitely unlikely. From this perspective, the philosophical meaning of Earth becomes clearer. It is not just a rock in a habitable zone. It is a narrative laboratory where the universe experiments with complexity, with emotion, with ethics. Our stories, our works of art, our acts of kindness and our failures to live up to our own ideals. All of these are chapters in a book that may not be written anywhere else. There is a gentle irony here. The more we understand about cosmic insignificance, the more we are pushed toward moral significance. If we are truly tiny and possibly alone, then how we treat each other on this tiny world matters immensely. Every child who learns to look at the night sky with curiosity rather than fear. Every scientist who adds one more piece to the puzzle of nature. Every person who chooses empathy over hatred is participating in something far larger than their individual life. In this sense, the future of Earth and humanity is not just a scientific question. It is a spiritual and philosophical one. Will we use our brief window of awareness to fight over illusions of separation, or to explore, to understand, to protect the rare oasis that has given us a stage on which to exist at all? Will we let our technology outpace our wisdom? Or will we grow into a civilization that sees itself as a guardian of consciousness rather than its accidental host? As you imagine our small planet drifting through the darkness, held in the gravity of a star that will one day fade, there is a particular calm that can wash over you. You realize that your life is both impossibly small and unimaginably meaningful. A single note in a symphony that might be playing in only a few places across all of time and space. And so we come back to the paradox that began this reflection. Earth is tiny to the point of near non-existence when measured against the universe, yet priceless when measured in terms of life and awareness. Between these two truths, we find a way to live, humble in scale, but vast in responsibility.